To introduce the topic of average value of a function, I want to start by saying, let's say you took two tests. You got a 90 on one test and you got a 100 on the other test. This is out of 200, but that's okay. 90 on one and 100 on the other. Well, what you would do to find the average test scores, you'd add the two numbers up and you divide by 2. So you get 190 divided by 2 and you get 95. Okay, so 95 would be your average score. Okay. Well, the average value of a function, though, if you look at let's say you look at the graph of a function, okay, on the interval from a to b, let's say, and if you want to find the average value, the values of the functions are the y, okay, the y coordinate or the y value, how high one little line is, let's say. And so finding the average value of a function, if you add up all the different values, now there's an infinite number of them. Remember, when we integrate, we add up an infinite number of rectangles, rectangle areas. Well, this gives us, when we integrate, we get the average, or we get all the values of the function added up, and so we get all the y's, so we get that whole area. Okay, well, the average value of a function, you can see here to be the integral divided by the distance between a and b. So basically the number of rectangles would be all the distance from a to b if you wanted to relate it to that kind of finding the average test score. But the way I like to think of this as integral, the average value of a function, is what I call integral divided by interval. Okay? So it's similar to adding up all the numbers and dividing by how many numbers there are. Well, we're going to be adding up all the areas, so we get the entire area, divide by the length of the interval. So we have integral over interval. So if you can remember that, makes this process very simple. I should also point out that average value of a function does not mean average rate of change of a function. So be really careful that the average rate of change, if you're asked that question, that you don't use the formula for the average value of a function. These are two totally different things. Value of a function and rate of change of a function, those are two different things. And so try to keep those separate in your mind, and so you don't make that careless error that many students make. So we're going to find the average value of, we have the formula, what we have to do is plug it in here. So the average value of this function here, 4 minus x squared on the interval from 0 to 3, is the integral 4 minus x squared dx from 0 to 3 over the interval. The interval is 3 minus 0. Okay? And so we know how to find the antiderivative of, let's write it like this, 1/3 times. Okay, the antiderivative of 4 minus x squared, we know that's 4x minus x cubed over 3. And we're going to evaluate that on the interval from 0 to 3. Okay? Well, then we're just going to, I'm going to try to leave a little bit more room here. We have 1/3 times, now 4 times 3 is 12, minus 3 cubed over 3. Okay, minus, and then 4 times 0, minus 0 cubed over 3. I'm doing this so that you are reminded how to evaluate a definite integral. So really all this stuff over here, 4 times 0, 0 cubed over 3, that all goes to 0. 4 times 3 is 12. So we have 1/3 times 12 minus 3 cubed, which is 27 over 3, is 9. So we have 12 minus 9, which is 3. 3 divided by 3 is 1. So the average value of this function, 4 minus x squared, on the interval from 0 to 3 is 1. Okay, let's take a look at what that looks like. 4 minus x squared, we know that to be a parabola opening down, 1, 2, 3. Okay, and so really what we have, the integral is, what do we say the integral was? 3. And so we have all this area here minus the area here. That has a value of 3, and then we divide that by 3, and we get 1. Okay, we'll take a look. The next part of it, does f actually take on this value at some point in the given interval? Well, yeah. we know that this value up here, the y value, is a high point of 4, because that's 4 minus x squared. So we have a y-intercept of 4. So somewhere in here, right there, we have the value 1. So right there, on this curve, the value of the function is 1. And what's the x value there? Well, to figure that out, we would have to figure out, well, we'd have to set 4 minus x squared equal to 1. And when you solve this, you subtract 1 from both sides. You get 3, and then add x squared to both sides. You get x squared equals 3. So normally x is plus or minus radical 3, but we can see that in this case we're only looking at the positive square root. So when x is equal to radical 3, this function has a value of 1. Okay, that's over on the positive side. Now, if we did extend this to the second quadrant, then we would see over here at negative radical 3 as well, the value of the function would be 1. So the answer to that question, does f actually take on this value at some point, is yes, it does when x is equal to radical 3. Okay, and that leads us into, finally, the mean value theorem for definite integrals. Okay, the mean value theorem says that if f is continuous on this interval from a to b, then at some point c on that interval, f of c does equal the average value of the function. Okay, and so that's one of those theorems that we're going to spend more time on as we get more prepared for the AP exam. But it is one of those things where you get maybe one question on the next week's test on that, where what would that x value be? And then some of the homework that you're going to get tonight is going to help you with that. But there you go. There's the average value of a function, short and sweet, and it's just the formula. You just have to remember integral over interval. So if I'm going to summarize this, I'm going to say that integral over interval is the average value of a function. And once again, guys, not to be confused with the average rate of change of a function. So hopefully that helps, and I will see you in class. Make sure you do the problems that I listed on Canvas. Okay? Have a great night, and I'll see you on Friday.